I'm going to add the Solidify modifier to this two-dimensional mesh. Even in its default setting, you will immediately see how it adds depth to this cookie logo. There are two modes, simple and complex. We'll focus on the simple mode for the time being. The thickness setting dictates the amount of thickness that is added. It is measured in real-world units, and since my default Blender units are meters, I will set this to 0.005 or 5 millimeters. The direction in which the thickness is applied is in relation to the face normals. The original mesh is sitting at the world origin, and because the default offset is -1, the Solidify effect is applied in the negative direction to the face normals. Setting the offset to 0, the Solidify effect is evenly distributed in the positive and negative normal direction. And setting it to 1, the Solidify effect is applied in the positive orientation in relation to the face normals. I'll set this back to 0 for the rest of the demonstration. The even thickness setting will adjust your mesh when it encounters sharp corners. Sometimes the modifier doesn't approximate the desired effect, and this cookie has a couple of sharp edges, such as this, which could benefit from enabling this setting. By default, the rim setting Fill is activated. If we deactivate this setting, you can see that the rim between the original faces and the newly created parallel face vanishes. By adjusting the thickness, you can see that this affects the distance between the original face and the parallel face. Let's bring the rim back and enable Only Rim. Now from this angle, it looks like nothing appears to have changed. But if we flip to the other side of the object, you'll see that there is no parallel face that is generated. Here I have duplicated the mesh and assigned two vertex groups. Group 1 is the cookie on the left. Group 2 is the cookie on the right. We can assign the Solidify modifier to a specific group. In this case, let's assign it to Group 1. You'll also notice that there is a factor setting, and by increasing this, you can incrementally apply the modifier to anything that is not assigned to Group 1. You can also apply the modifier to the inverse selection of the vertex group. To demonstrate how the modifier can be affected by the direction of the face normals, let's take a look at this shallow cylinder. We'll enable the face normals in our overlays so we can see what direction they are pointing. Simply enabling Flip won't show these reversing in edit mode. I'll disable the setting, go back to object mode, and activate Only Rim. You'll notice that the parallel faces now have disappeared. If we flip the normals, you'll see how the opposite faces vanish. Let's now take a look at the material settings. The first is the material offset, which dictates the material assigned to the parallel faces. When everything is set to 0, these faces will simply adopt the original material of the object. Let's disable the rim for the moment and go into rendered mode. Let's take a look at my material settings. Here you'll see that I've already assigned 3 materials to this object: orange, black, and white. The orange material at the top of the stack is what is currently shown. Let's go back to our modifier properties and change the material offset from 0 to 1. You'll now see that the parallel faces have adopted the second color in our material stack. I'll assign an offset of 2 for the parallel faces. And now if we re-enable the rim, we can assign a material to offset just the rim separately. In this example, we'll take a brief look at the edge data settings. I've added Solidify to this plane. I've also added a subdivision surface modifier after Solidify. Let's increase the thickness to 1 meter. I'll remain in edit mode, but I'll make sure we can see the modifier changes while we're in edit mode. However, I will keep the on cage setting disabled so we can see the original plane. If we increase the inner crease slider, you'll see this affects the parallel faces, flattening them out, thereby overriding any subdivision that the next modifier will apply. Setting the outer crease to run will do the same for the original faces. And increasing the rim edge data will make the subdivision modifier redundant, as all edges now appear to have an edge crease of 100%, and this will override any data which could be smoothed out by the subdivision surface modifier. Bevel Convex looks for bevel weight data you might have added to edges or vertices, and can adjust how the weight is distributed for modifiers that rely on bevel weight data lower in the stack. I've added some bevel weight to this edge here. I'll add the Solidify modifier to this mesh. I'll enable even thickness, and I'll give it some extra thickness so that we can see this effect more clearly. Now I'll add a bevel modifier after our Solidify modifier and set the limit method to weight. I'll give this about 6 segments. You can see how the bevel is transferred to the inside wall of this solidified mesh. Moving the bevel convex setting in the negative direction will reduce the inner wall's bevel until it is no longer apparent. Moving the bevel convex in the positive direction will be able to control how much bevel is added to the non-weighted edges and vertices until the entire exterior solidified mesh behaves as if everything has a bevel weight of 1. Note, however, that the inner wall will only display the bevel on the edge that the bevel weight is applied to. The thickness clamp will help prevent you from creating intersecting geometry. An example where this could happen would be something like this simple bowl. I'll add the Solidify modifier to it, and I'll increase the thickness quite dramatically. I'll enable X-ray so that you can see that the resulting geometry actually intersects in the narrower section of this bowl. This means that if we were to apply the modifier now, the resulting geometry would require some cleanup. So instead, let's use the thickness clamp to solve our problem before we even get to that step. We can increase this clamp to a soft upper limit of 2, although if you require, you can push it beyond by typing in a larger value. The clamp will examine the distance between the outer and inner walls, so if the resulting geometry is smaller, it will create a thinner wall. Enabling angle clamp changes the clamping method from the distance between outer and inner walls to the angles between faces. On this open cylinder shape, I'm going to go to its data properties and create 2 vertex groups. I'll call one shell and the other rim, but I won't assign any vertices to them. In my Solidify modifier, under Output Vertex Groups, I'm going to add the shell group to the shell section and the rim group to rim. Now I'll apply the modifier. When I tab back into edit mode and take a look at my cylinder's data properties, the vertices that were generated as the shell and the rim have now been applied to the corresponding vertex groups. If you apply and you discover that the wall is incorrectly attributed, undo a couple of steps, flip the normals, and reapply. The simple mode works great for most cases. But when you have meshes which show non-manifold topology, angled or scaled extrusions, or even holes, then you're probably going to want to use the complex mode. Here is a model to which, when I add Solidify to it, it will immediately show problematic areas. We could try to adjust a few things. Perhaps set the offset to 0, try and enable even thickness, and even adjust the thickness to a level which is the least problematic, but we will still not produce an optimal result. Switching over to complex, you'll notice a couple of differences. First off, the even mode is no longer an option, but what we have is a thickness mode and boundary setting. The thickness mode has 3 settings. Fixed is the simplest, and if we compare it to the simple setting, we see that it performs slightly better on thickening the walls of this mesh. Even will produce a much nicer result. And constraints might seem like it makes this area, for example, worse, but when we look at boundaries and how to set these correctly, you can see where constraints comes in handy. To understand boundaries a little bit more clearly, let's take a look at these 3 open cubes, which I've duplicated with Alt-D, so editing one will edit all of them. I've added a Solidify modifier to each of these, but I've set each to a different boundary mode. As I edit this open boundary, you can see how each reacts a little differently, hinting at some uses you might encounter. None is fine for a mesh which is simple and even, but if, however, you have areas in your mesh where you want the walls to have proportionally even thickness, round is a good setting. And if you wish those boundary areas to be angled as if they've been planed, then flat is the best option. Back to our complex model, with the thickness mode set to even and our boundaries set to round, looks passable. And setting our boundary to flat, the back curved wall shows some serious artifacting. Now let's set our mode to constraint. This corrects any problems with the curved wall. All the other settings will adjust your mesh as with the simple mode. Using all of these settings in conjunction, you should be able to tackle and correct for most situations.